Hey, how you doing? I'm Michael Singh.
I'm James Coffey.
And I'm Dustin Sims, and our final project for ELCT 201 was a smart room using the Photon.
The materials used for this project are two 12-volt power supplies, a servo DC motor, our Photon, and our Embed microcontroller. Also, the components being used on this project is a thermistor, various LEDs, a speaker, 10K turn pot, and an IR sensor.
This is the schematic for our project, which includes our Photon module, our embed, and our various components. Some of the components included in this project are a speaker, thermistor, amplifiers, LEDs for temperature readings, trim pot, motor, and this is our H-bridge that actually runs our motor, and our two 12-volt power supplies, and last, our IR sensor.
To scale the 3.3 volts from the Embed module, we use the point slope formula in order to find the scaling factor. Once finding the scaling factor, you multiply that by the feedback voltage coming from your 10K resistor, and you will get the value you need to put in your C++ code for the Embed microcontroller.
We created a work breakdown structure so we could stay on task and complete due dates on time for the smart room. We completed this by splitting it into three major categories: hardware, software, and the presentation. And you can just look and you can see the task we outlined when they were due. Some of the major problems we encountered while we were building the smart room was we had to know the position for the blinds, so we ended up attaching a servo 10-turn pot so that we could know what the location was of the blinds at all times, so that we could stop them at a certain spot when they were open or when they were closed. Also, the embed doesn't have an onboard function generator, so we had to figure out a different way to power the alarm system that goes to the speaker. So we used a Photon, and it creates a square wave, which we actually used that to power the alarm system. The H-bridge was breaking regulation, so we had to figure out a way to get all the excess voltage out of the gates and switches. So the way we actually countered that problem was we used a resistor from the H-bridge to ground, and that got rid of any of the excess voltage.
So we believe this smart room project for future thoughts can be scaled up, utilizing a lot of the signals that people use in their everyday lives to take care of the meager tasks that people usually don't want to deal with.
All right, the functionality of the smart room that makes it important is that it has automatic and manual starts. So the automatic start would be if you walked into the room, and we used an IR sensor for that, which would be when you walk into the room, turns on the lights, and the blinds would open like if you had a window. And we also used a speaker, so like if somebody walked into your room when you weren't there and you wanted to trigger an alarm to try to scare them off, you could do that using your phone.
Also, the smart room is capable of manual starting and manual stopping with the use of your cellular device, Tinker app, and your Photon microcontroller.